All right, this is a recording on the application we did in class on Tuesday on projectiles. The problem was on a handout, week 6B, applications of quadratic functions. The story is a child is playing in his backyard and throws a baseball straight up in the air while standing on the platform of the slide. The function that describes the height of the ball t seconds after it is thrown is minus 16 c. Minus 16t squared plus 30t plus 4. The first question is, what is the height of the platform? And so this question can be answered by letting t equal 0, meaning that, so the height of the platform is the initial height of the ball, and the initial means beginning, so when time equals 0. So the height of the platform is 4 feet. Part B says, what is the ball's height after 1 second? And so we plug in t equals 1. We get minus 16 times 1 squared plus 30 times 1 plus 4. And we make that calculation and get 18 feet. So the ball is 18 feet high. 1 second after the ball is thrown. We're going to skip the average velocity question and go to how long is the ball in the air? So the kid's standing on the slide. He throws the ball up, and the ball goes up and comes down. Now, this is time, so the ball goes straight up and down, but its height as time progresses is a problem. And so the length of time the ball is in the air is from the time he threw it at t equals 0 until it hits the ground. So we need to know the x-intercept. So to do that, we are going to use the quadratic formula. So minus 16t squared plus 30t plus 4 equals 0. So when the height is 0, we've hit the ground. So there's A, B, and C. And what we're going to do is calculate what's called the determinant. So that's B squared minus 4AC. So B squared is 30, or B is 30, so we get 30 squared minus 4 times minus 16 times 4. So that's AC. And putting that into the calculator, we get 1156. So the solution using the quadratic formula, so the quadratic formula is minus b plus or minus b squared minus 4ac all over 2a. And now this is that part, that's b squared minus 4ac. So I can rewrite that part right away, 1156. B is 30, so we get 30 plus or minus the square root of 1156 over 2 times minus 16. And that bottom should be in parentheses, and really the top should be in parentheses as well. So let's get our calculator and make this calculation. Okay, come on. So minus b, so minus 30, we'll do plus the square root of 1156 Okay. What? Well, this is annoying. I think we'll be okay. So the top is apparently 4 over, there is no way that can be right. Oh, well, okay, that's going to be our negative one. Our negative, so when we think about the boy is standing on the slide and throws it, but there's a part back here. So that's not the one we're interested in. Let's see if we can get the calculator to cooperate. All right. Let's see. Well, maybe I can figure it out. Okay, 11, so minus 30 plus the square root of 1156 is 4. So if I do, that must mean that 1156 is, the square root of 1156 is, okay, never mind, I found a calculator. We'll just do it with, okay, so minus 30 minus the square root of 1156, that's minus 64, and then I divide that by minus 32, and I get 2. I really did not, okay, so the ball was in the air for 2 seconds. So that answers part C. Part D, what is the maximum height of the ball? So to answer the maximum height question, we need to find the vertex. So that's HK. It's in general form, so we're going to use the formula minus B over 2A. So remember that B is 30, and we have 2 times minus 16. So 30 divided by 32 is let me convert it to fraction. There it is. So 15 over 16. So that's when it meets its seconds. This is when it reaches its maximum height, and the maximum height is, we plug that into the function, so we get minus 16 times 15 over 16 squared plus 30 times 15 over 16 plus 4. So we get minus 16 times 15 over 16 squared plus 30 times 15 over 16 plus 4. And that is 18. 18.0625. So right at 18 feet, and it happens right around 1 second. And so that's that problem.